Hey everybody, so today we are going to take a look at all the review questions in this video, and there's a separate video for the Chapter 2 sample test questions. And the first one, actually for the first three questions, they go with the conditional statement. If the measure of angle 1 equals 120, then angle 1 is obtuse. So question 1 says write the hypothesis and conclusion of the conditional. The hypothesis would be the measure of angle 1 equals 120, and the conclusion would be angle 1 is obtuse. Remember that for the hypothesis you don't include the word if, and for the conclusion you don't include the word then. So angle 1 is obtuse. That's our conclusion. Okay, when we write the converse, we switch the hypothesis and conclusion. So our converse will be, I'm sorry about the spelling error there, if the measure of angle 1 is obtuse, then the measure of angle 1 equals 120. And the next question, number 3, it says provide a counterexample to disprove the converse. So a counterexample is an example where the hypothesis is true. So the hypothesis is always true, but the conclusion is false. So in this statement, if the measure of angle 1 is obtuse, does it have to be 120 degrees? And that's false, because the measure of angle 1 could be 100 degrees. So as long as you give the measure of an obtuse angle, so something greater than 90, then you're all set with your counterexample. Number 4, we're asked to write the definition of a straight angle as a biconditional. So a biconditional would use that special phrase, if and only if. Okay, a straight angle is an angle whose measure is exactly 180 degrees. Okay, so an angle is a straight angle if and only if it has a measure of 180 degrees. That's it. In questions 5 through 8, we're asked to justify each statement with a property from algebra or a property of congruence. So number 5, it says that if the measure of angle A plus the measure of angle B plus the measure of angle C equals 180, and the measure of angle C is equal to 50, then the measure of angle A plus the measure of angle B plus 50 degrees is equal to 180. All right, now I know we've looked at the transitive property a lot lately. This is not an example of the transitive property. If you check it out, this one ends with 180. The next phrase starts with the measure of angle C. So it's not the transitive property. But what's happening is that the measure of angle C is coming out and 50 is going in its place. So that's the substitution property of equality. In number 6, it says if the measure of angle A plus the measure of angle B plus 50 degrees equals 180, then the measure of angle A plus the measure of angle B is equal to 130. So you have to ask yourself how that happened, and that happened by taking and subtracting 50 from both sides. So that's an example of the subtraction property of equality. Number 7, it says if 6x equals 18, then x equals 3. So how that happens is by dividing both sides by 6. So it's the division property. And finally, it says if AB equals CD, or AB, is congruent to CD, and CD is congruent to line segment EF, then AB is congruent to EF. And this, my friends, is the transitive property. Now, we talked a little bit about how sometimes it seems like you could use the transitive property or the substitution property. Notice that these are congruent symbols. So if it's congruent, you cannot use substitution. Remember that if we want to use substitution in our proofs, how we change everything to equations, so we can do that. Okay, a little more practice with our postulates and theorems. So number 9, it says, if line segment RS is congruent to ST, then S is the midpoint of RT. That's the definition of midpoint. A midpoint is the point which divides a segment into two congruent segments. And that's what's going on here. So it's just the definition of what a midpoint is and what it does. It's not the midpoint theorem because it doesn't say that each of those segments is half of RT. All right, number 10, we have information that says if ray SW bisects angle VST, then angle VSW is congruent to angle WST. And again, that's the definition of something, the definition of an angle bisector. Now contrast this with the next one. Number 11, it says if SW bisects angle VST, then WST, that smaller angle, is half of the whole angle. This, my friends, is the angle bisector theorem. Okay, number 12, it says if angle BOC is a right angle, so I'll mark that in there as 90 degrees, and the measure of angle COD equals 58 degrees, we have to find the measure of angle DOE, the measure of angle BOA, and the measure of angle AOC. Okay, so if angle BOC is a right angle, then this is a right angle over here too, because we know from the picture that BOE is a straight angle. So take and subtract the 58 from 90 degrees, and we end up with 32. So the measure of angle DOE is 32 degrees. Right, that means the measure of angle BOA is also 32 because they are vertical angles. And we have not a definition, a theorem that says vertical angles are congruent. I was about to remind you that we never use the definition of vertical angles because it's awkward and really hard to pin down an exact definition for vertical angles. All right, finally, the measure of angle AOC, and just highlight that in blue here. This is angle AOC is this whole angle. So we're going to use a little angle addition. Take and add the 90 plus the 32. I get 122 degrees for angle AOC. All right, I'm going to clean this up a little bit and answer the last question for this diagram, which says name the supplement, or name a supplement, of angle AOE. This angle is angle AOE, so you can look at it in one of two different directions. You can continue on and form the line right here. So right here we have a straight angle. So one supplement of angle AOE could be this angle, angle DOE. You could also look at this in the other direction, and we have angle AOE and angle BOA, this angle. They would form this straight angle. You only have to name one, and you only have to name it one way, so you don't have to list it as angle EOD or angle AOB. Okay, now for the word problem. Everybody's favorite. It says the supplement of a given angle is 4 times as large as the complement of the angle. Find the measure of the given angle. So recall from our time in class, we said first represent the angle with x, represent the supplement with 180 minus x, and represent the complement with 90 minus x. And then go back and read the word problem again. It says a supplement of a given angle is. So replace a supplement of a given angle with 180 minus x. Okay, next, for the word is, that's where we put our equal sign into the problem. Then it says that it is 4 times as large as a complement of the given angle. So we want to do 4 times the complement. So 4 times 90 minus x. So 180 minus x equals 360 minus 4x. I would probably add the 4x to both sides and make this 180 plus 3x equals 360. And let's move this up a little bit. Take and subtract 180 from both sides, so you get 3x is equal to 180, or x is equal to 60. We don't have to find the supplement and the complement, but certainly you can do that if you wanted to check it out. So this is 60 for the angle, the complement would be 30, and the supplement would be 120. So check it out. Is the supplement 4 times the complement? It is. 4 times 30 is 120. So we're right. Okay, for 15 through 18, this is name the definition or state the theorem that justifies the statement about the diagram. In number 15, it says if ray KJ is perpendicular to line GH, then angle A is a right angle. This is just the definition of perpendicular lines. If lines are perpendicular, they intersect to form right angles. All right, or you can say it's a 90-degree angle, which leads us to number 16. It says if angle 2 is a 90-degree angle, then KJ is perpendicular to GH. That's also the definition of perpendicular lines. All right, and number 17, we're switching things up a little bit. It says if ray NM is perpendicular to GH, then angle MNK, right here, is congruent to angle MNH. So this one, we're going to have a theorem. If two lines are perpendicular, they form congruent adjacent angles. And you would use this in a proof if you know that the lines are perpendicular and you're trying to prove a pair of angles congruent. This can be a really handy theorem. Okay, one more for this diagram. It says if ray NM is perpendicular to GH, then angle 3 and angle 4 are complementary. All right, so we've got this ray perpendicular to this line, and we're saying that 3 and 4 add up to 90 degrees. So this one's a theorem, and it goes like this. If the exterior sides of two adjacent acute angles are perpendicular, then the angles are complementary. All right, on to the proof. Okay, next we're going to take a look at questions 19 and 20. 19 just asked you to write a plan for the proof, like kind of do your thinking about the proof, and then 20 actually asks you to write the proof. So these two just kind of go hand in hand. So the planning for the proof, you can do that, in your head first. It's always a good idea before you even start to write anything in the statements or reasons. So with proofs, sometimes there's more than one way to do a proof. So don't be locked into thinking that just because I show you one way that is the only way to do a proof. There can be other ways. It's usually the case that if I show you a solution for a proof, I'm going to show you the most efficient way possible to do the proof. And by efficient, I mean in the fewest steps. It may mean that I'm using the theorems that are kind of, the harder ones to memorize, the longer theorems, but the longer theorems often give us the shortcuts, okay? So first, just read through the given information. It says angle 3 is a supplement to angle 1, and angle 4 is a supplement of angle 2. So you could take the direction where you say after the given information, you could write some equations and say the measure of angle 3 plus the measure of angle 1 equals 180, and the measure of angle 4 plus the measure of angle 2 equals 180. You could do that, but that would make your proof at least one step longer and possibly a couple steps longer. So let's check this out using one of our new theorems. Right? If angle 3 is a supplement to angle 1, and angle 4 is a supplement of angle 2, and that was given to us. Let's see what we can discover about angles 1 and 2. Check out your picture. Right here, I can see that angle 1 and angle 2 are vertical angles, so therefore they're congruent. Remember that this is just that easy theorem. Vertical angles are congruent. Not the vertical angle definition. We never will use that as a reason because the definition of vertical angles is really awkward. Okay, we're ready to make our final conclusion. All right, if 3 is supplement of 1 and 4 is the supplement of 2 and 1 and 2 are congruent, then that means that angle 3 has to be congruent to angle 4. So we don't have any equations. We don't have to change back and forth between equations and congruence and vice versa. I'm going to say simply the theorem from section 2-6. If two angles are supplements of congruent angles, then they are congruent. Then the angles are congruent. Just to make it a little bit clearer that we're talking about the two angles over here, 3 and 4. All right, that's it for the review. Now, if you haven't done so, complete the chapter test, the sample test from the book, and then watch the video to check your work. All right, good luck, you guys.